here. And those are the extraocular muscles. And they should look like meat because they are muscle. And you'll see varying amounts and lengths of those extraocular muscles around the outside also. You're not going to have to identify them on the sheep eye. Okay, so once we've identified those things, take some of this connective tissue stuff and pin it to the wax of your tray to anchor this guy. And then what we're going to do is cut. If you look at the whiteboard instructions, you're going to cut with a nice new scalpel blade from 12 to 6 o'clock, top to bottom, across this eyeball, and 3 to 9 o'clock or side to side, across. And then we're going to squeeze it from behind and push the lens and vitreous body out. So I'm going to do that first to show you the procedure, and then I'll take my gloves off and show you what we're looking at with this model. Okay, so I can feel the tension with my gloved finger that I've created by pinning it nice and tight to the wax. And then sometimes it will squirt at you, so you might want to just step back and turn your head a little bit.
Or watch.
You put more pressure than you would think behind your blade.
I know.
That's pretty good.
Now you see that water coming out the front, dribbling out? That's the fluid in the anterior chamber of the eye. It's aqueous, watery. That's our aqueous fluid. What's still in there right now that we want to remove is the vitreous body with the jelly-like vitreous fluid within it. So I've done my first cut. Now I'm going to squeeze.
Oh my gosh.
There it comes.
Gosh.
There you go.
Sorry guys, that was just really cool.
It's like one of those early pimples you see on YouTube.
That's what I was thinking.
And then you want to have a white paper towel ready, because what we've just taken out is the vitreous body, and if on the black wax you're not going to see this nice black halo of suspensory ligaments at the front of the vitreous body. So here's the body itself. It's jiggling with that gel-like vitreous fluid inside. Yeah, you can. It kind of slips between your fingers. Right in the middle here where I'm touching my gloved finger, we'll see the lens. Now these eyes have been frozen and thawed, so sometimes the lens is still really nice and convex. Other times it's kind of flat and more deteriorated like this one. This is what we have diagrammed here on the right-hand side of the whiteboard. So that black halo, those are the suspensory ligaments that keep the lens in place. When they pull, they cause the lens to flatten, and when they relax, they cause the lens to bulge. And the lens bulges and flattens to accommodate the light waves coming into the eye so that they focus on the retina appropriately. And it's the accommodating part of the eye that's constantly changing its shape to create a perfect image on the retina. Okay, now I just squeezed out the rest of what was still inside the eye. This is the retina. It looks like kind of a transparent, collapsed parachute, just streaming out right there. Not much to it, considering how important it is. It would be really easy to overlook. And if you pull taut on it, you'll see that it's attached at the back of the eye, and with a blunt tip probe, you'll be able to see that point of attachment. That is the optic disc. That is an area where all of the nerves that are part of the retina are converging toward the optic nerve that's leaving the eye and going toward the brain. So right there, we do not have the ability to focus an image, and it's called your blind spot. That optic disc is your blind spot. Okay, you want to make your lateral incision, and then maybe finishing up with a pair of scissors, you're going to pull this eye apart and perhaps wash it a little bit with some humectant. When you look at the back of the eye, in this case, this animal eye, you're going to see kind of an opalescent color. That's called the tapetum. It is kind of pretty. Looks like the inside of an abalone shell. The tapetum lucidum is kind of a bluey green color back there. And again, if we wash it out with some humectant, it becomes more apparent. That allows light waves to bounce around to a greater degree inside the eye. And in animals, especially those animals that are most active at dusk or dawn when light is low, That's really helpful because it increases their visual acuity in suboptimal light conditions. Okay. We have something like that in the human eye, and that's what makes your eye look red when you take a photograph. Sometimes red eye, but so it's not the same color in the human.
Which sexes are different for like nocturnal animals?
That would be the primary one.
Okay.
We also have in some animals what's called a nictitating membrane that slides down over the eye even when the eyelids are open. And so if you've ever seen your cat, if you have a cat at home start to doze, you've seen the nictitating membrane kind of slide down and over the eye. Looks like a filmy eyelid below the fleshy eyelid. So animals will have those modifications too, terrestrial animals. Now there are two ways to dissect the eye. You can do a frozen eye, which is nice because then you can just kind of lop the top off and look into the intact chamber. But then you can't push the vitreous body out. When we do it this way, not frozen, we can get a good handle on that vitreous body, but unfortunately when we squeezed it to bring it out, we kind of destroyed the inner chamber of the eye. So at this point, having identified that much, you can take your gloves off, open up one of these models, and see what, this one's kind of messed up in here. Oh, what happened? See what we were working around when we did this dissection. Okay, so if I take the top off, what are we looking at? This larger posterior chamber is where we see the vitreous body. That is where this came from. So we squeezed from behind and we pushed it forward, and when we did, all this, we cut through this, but the lens was pushed out, and the lens is resting right in the middle now of that vitreous body. So the suspensory ligaments on this model are represented by this kind of brown color here. They're holding that lens in place. Here's the little muscle called the ciliary body that causes those ligaments to become slack or taut and causes the lens then to bulge or flatten. Okay, you can see that, and it looks like muscle in cross section here. That vitreous body, the fluid pressure within it is really important because that's what presses this retina, orange on the model, against the rear wall of the eye. If the retina detaches, then it's removed from the inner layer called the choroid, represented in red right here, or pink in this cutout section on the top of the model. Choroid is blood supply. So if the retina separates from the blood supply, you know what happens when you have no oxygen, tissues die, retina dies, and then it's a neural tissue, so does it grow back? No, it doesn't regenerate, and blindness can result. So detached retina will happen when we have impact to the eye that causes us to lose fluid from the vitreous body, and that retina being detached is no good because it can lead to blindness.
Where do you find a lot of that? Where do you find a lot of people
Usually
their retina's attached or detached?
Sometimes it'll happen in older people who have blood pressure issues that aren't being regulated well, but impact to the head is another situation where we would see that. So any kind of impact to the head, so most frequently car accidents, things like that, but certainly anything that involves impact to the head. Now, if we go in front of the lens, we're in a different chamber. We're in the anterior chamber. Now, the term segment and chamber, you'll see used interchangeably in the text in the lab manual. I don't care whether you say anterior segment, posterior segment, or anterior chamber, posterior chamber. But what you need to know that is that in the anterior portion, there are two chambers, and they're divided by the iris. So the iris sits right there. If we're in front of the lens at all, we're in the anterior portion of the eye. But if we're in front of the iris, we're in the anterior division of the anterior portion of the eye, sometimes called the anterior chamber of the anterior segment, or vice versa. Okay, I'm pretty lenient on whatever word you choose to use. Just know that there are two subdivisions of this anterior part, no subdivisions to the posterior part. Outermost is our cornea. It's the transparent part of the eye that the light waves pass through. So if I'm a light wave coming at the eye, the first thing I pass through is the membrane over the cornea, which is the conjunctiva, then through the cornea, through the fluid in the anterior chamber, through the hole in the iris called the pupil, through the fluid again, through the lens, through the vitreous fluid, and then finally I'll hit the retina. That's a lot of different things for light waves to pass through, and the rays of light become spread, and that's why we need this, because it's passing through so many different densities of media. That's why we need this lens to flatten or bulge so that we can make sure those light rays land right on the retina. If they don't, if we're not able to accommodate the light waves adequately with the lens, then the focal point is beyond the retina or short of the retina, and we are near or farsighted as a result. And we put corrective lenses in the front of the eye to remedy that so that we get it focusing right on the retina and we have a clear image of what it is we're looking at. Okay, that's a little bit of a digression into phys just so that you could understand what we're looking at in terms of the anatomy. Okay,